Okay, class, before we get started, I need to know, were there any questions from the last class over anything we covered during the last class? Any questions? Okay. Well, today we're going to go over sections, I believe it was 1-6, 1-6 and 1-7, I believe it is. Let me take a look here just to be certain.
I think it's 1-7 to 1-8.
Yes, it's 1-7 and 1-8. Okay, so we're going to cover 1-7 and 1-8 today. Now, what I want you all to pay close attention to, I wrote a little note under 1-7 and 1-8. The only problems that I want you all to do are the odd problems. So on the page, you don't have to do the even problems, just the odd problems. Now, have any of you received your textbook yet?
Yeah, mine was mailed to me yesterday, so I have my textbook in front of me right now.
Okay. Is there anyone on here that does not have their textbook?
Mine's supposed to be here tomorrow.
Oh, okay.
I don't have it yet.
Okay. Have you
I
heard?
don't have mine yet either. Next week.
Oh, they say next week for yours?
I'm out of state, so they have to ship it to me. It's on its way, but I won't get it. It doesn't say until Tuesday.
Oh, till next Tuesday. Okay. So what I have been doing, I've been copying the pages. So it's still, it's still in JetNet. But maybe by next Tuesday, I'm assuming that you probably will get your textbook, about time for class. So probably by next Tuesday, I probably am going to stop uploading the sheets because you'll have your textbook by then, and that's what we will be going by. Okay, so are there any questions? All right. Okay, is anyone still having trouble getting into my math lab? Okay. All right, so this is what I'm going to do. Well, I see someone typing. Let's see. Okay, what I'm going to do, I'm going to put you in the breakout rooms, and you'll be in there for about an hour to go over 1-7 and 1-8. And I'll be joining you all, and Alea will be joining you all probably in about 10 minutes. And then we'll shift from room to room like we have in the past. So if there's no other questions right now, I will put you in your breakout rooms. Hey class, we are back here and I'm going to go over the problems that we were supposed to cover today in 1-7 and 1-8. I asked you all to do just the odd problems from 1-7 to 1-8. So in 1-8, well, 1-7, we're only supposed to go 1, 3, 5, 7, and 9. And then 1-8, we're supposed to do 1, 3, 5, 7, 9, and 11, if I'm not mistaken. So let me go through this. I pulled up the textbook from my math lab. And as you see, it's a little clearer here. It's on page 66. Let me go through this. It says, number one, determine whether the following functions are linear. That is, determine whether the average rate of change is constant. Okay, when we look at A here, we got X and Y, we have 0, 1, and 2, and -1, 9, and 19. Okay, now these are our points. Now what you're supposed to do is look at your X values and look at your Y values to see if any of them are consistent. So if you look here at your X value, each of these values are going up by 1. So because your X values are going up by the same amount, your Y values must go up by the same amount too in order for it to be considered linear. So if you look here going from -1 to 9, you're going to add 10. from going 9 to 19, you also add 10. So we already know that this is a function, because if you look at your x values, we do not have any that repeats. So we know this is a function and it's linear because you have a constant rate for your x and y values. So it's linear, it is a linear function. And then it asks you to determine whether the average rate of change is constant. Now, the average rate of change, now that's a fancy way of saying when we're dealing with a linear equation, that's a fancy way of saying the slope. We want to make sure that the slope is constant. Now, what you can do, you can take these values here because slope has a few formulas. You can have the change in y over the change in x. And if you notice here, the change in y is 10 and the change in x is 1. So your slope would be 10. Now that's one way of doing it. Now if you don't remember that way, you can do it the traditional y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you would pick any 2 points here. I'm going to pick the first and second point. Y sub 2 is 9. And y sub 1 is negative 1. X sub 2 is 1, and x sub 1 is 0. So this would be 9 plus 1 over 1, which would give us 10 over 1, which is 10. So your slope here would be 10. But the one thing that you would have to do here, though, you would have to do another set of points in order to prove that it actually works. So we would have to do the second set as well, using the same formula. Y sub 2 is 19, y sub 1 is 9, x sub 2 is 2, and x sub 1 is 1. So that still gives us 10 over 1, which is 10. So this is a linear function, but then we would say the constant rate of change is 10. So it's a linear function, and the constant rate of change is 10. Okay, that is A. Now we go here to B. We have this table here. Okay, now if we look here at our x values, we notice when we go to 2 to 4, we're adding 2. 4 to 6, we're also adding 2. So that means since this is consistent, since the change in x is consistent, the change in y is supposed to be consistent as well. But if you go from 11 to 8, you're subtracting 3. From 8 to negative 1, you're subtracting 9. You do not have the consistency there. So then it'll just be no, not linear. You don't even have to go through all of the other steps. Okay, now C. Okay, we have this brace. Let me lower this a little bit. We have a brace and we have our parentheses, negative 218 to 9, and then 6, 0. Okay, now they ask us first. Well, first of all, we look here. To go from negative 2 to 2, we're actually, well, you know what? Let me do this. Did you have a question, Brianne?
No, I just started working randomly.
Oh, it's no problem, no problem. Okay, what I'm going to do, I'm just going to do a table here just to say consistent with what we've done. So I'm going to put all the x values here, which would be negative 2, 2, and 6, and all the y values, 18, 9, and 0. Okay, to go from negative 2 to 2, we're adding 4. To go from 2 to 6, we're adding 4. So x is constant, so that means y must be constant. To go from 18 to 9, we're subtracting 9. And from 9 to 0, we're also subtracting 9. So we do have our rate of change. So basically it'll be, yes, this is a linear function. And the constant rate of change is, now remember it's a change in y over the change in x, so it'll be not negative 9/4. That will be the constant rate of change. Okay, now we move on to D. Now D is a graph here. And if you look at this graph here, you see that you see a straight line. Okay. Now we could do that, but we know typically in math, a lot of times we need to prove what we believe. So we should pick 2 points on this graph here. If you notice, it hits here at negative 2, 0, and it hits here at 0, 4. So we have negative 2, 0, and also 0, 4. So we could do the slope. Y sub 2 is 4 minus y sub 1. X sub 2 is 0 minus x sub 1, which is negative 2. So this would be positive 4. 0 minus negative 2 will be 0 plus 2, which will give us 2. So 4 divided by 2 is 2. So we do have a constant rate of change here, which is 2. So our answer here would be, yes, it's a linear function. And the constant rate of change is 2. Okay, now we come here to E. We look at this graph here. Now, when you look at this graph, you don't have to do anything extraordinary with the graph. You could just look at it. Since they want to know if this is a linear function, this graph is a function. Because if you notice here, none of the x values will repeat. But it's not linear because linear means it's supposed to be a straight line. So based upon what we see here, we could say no, not linear. And we could basically leave it like this here, that is no, it's not linear. And if you need to do a further explanation, you could just put based upon the graph. It's not linear. All right, so that took care of problem number 1. Were there any questions from problem number 1? Okay, next, we're going to go to problem number 3. Now, again, I asked you all just to do the odd problems. So now we go to problem number 3. It says you belong to a health and fitness center. You and your friends are enrolled in the center's weight loss program. The charts contain input and output values. Assume that that week is input and weight is output. That represent the weight over a 4-week period for you and your 2 friends. Determine which charts contain the data that is linear and explain why. So basically, this is more of the same of what we just did. So let's go with A here. Now, if you look at A, so we have week, and we also have the weight. So we got week 1, 2, 3, and 4. And the weight is 150, 147, 144, and 141. Okay, now when we look at the week here, The week is constantly going up by a positive 1. It's going up by positive 1. So that took care of the week. So the week is consistent. So that means that the weight must be consistent as well in order for you to have a linear function. So to go from 150 to 147, you subtract 3. 147 to 144, subtract 3. 144 to 141, subtract 3. So it is a linear function. So you would put yes, and then the average rate of change is a constant. And that constant would be the change in y over the change in x. So that'll be negative 3 over 1 or just negative 3. So it should be negative 3 is the constant. All right, let's look here at B. All right, so we have the same 4 weeks. Oh, guess I created a 5th week. All right, so the same 4 weeks, you got 183, 178, 174, 171. So if you notice, the weeks are constant, positive 1. So in order for this to be linear, they must lose the same amount of weight for each week. So 183 to 178, subtract 5. 178 to 174, subtract 4. 174 to 171, subtract 3. So then this would be no, it's not linear because weight loss is not consistent. So it wouldn't be linear. All right. So now we go here to C. So C, we have our week, we have our weight. So we have week 1, 2, 3, and 4. All right. So now we have 160, 160, 160, and 160. Okay, now, whenever you have a situation like this and all of your y values are the same, so you could say that this equation is basically equal to y equals 160. When all your y's are the same, yes, it is a linear function because it forms a horizontal line, and we could say the rate of change is 0. Okay, now we'll move on to problem number 5. Now, if any of you have any questions, please let me know. Okay, problem number 5. It says determine the slope of the line that goes through the points 2, -7, and 0, 5. Okay, so we have 5a. We know the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is 5. Y sub 1 is -7. All over x sub 2 is 0. Minus x sub 1 is 2. So this would be positive 12 over -2, which would be -6. So the slope is -6. Now for B, it says determine the vertical intercept of the line. And we know the vertical intercept is just the y-intercept. So the y-intercept is when x is equal to 0. Now, if you notice here on this graph, oh, we were supposed to do 4 first, but that's fine. Let me see. We have these points here. Well, we're actually given the y-intercept here. So we could basically write that. So it'd be 0, 5. Okay, now, so we go here to C. It says, what is the equation of the line through these points? Write the equation in function notation. Okay, now, first of all, let's write it in regular notation first, and then we'll write it in function notation. Regular notation is y equals mx plus b. Now, function notation, if we're using f as the function, so we could do f of x, that will replace the y. And that's basically the only difference between this equation and then writing it as a function. So you have f of x is equal to mx plus b, but now we're going to substitute in values. The slope, we determined the slope here was -6. So m would be -6 and we'll bring down our x. B is the y-intercept, is the y value of the y-intercept, which would be 5. So this right here is the function. Now D, it says, what is the horizontal intercept? Now the horizontal intercept is the x-intercept. So what we could do, we could take this function and then solve for x. Now, if we're solving for x, x is when y is 0. The x-intercept is when y is 0. So f of x will be 0 equals -6x plus 5. We'll subtract 5 on both sides, and -5 is equal to -6x. We divide each side by -6, and then you have a positive 5, 6 is equal to x. So now we cannot leave it like this. We have to write it as an ordered pair. The ordered pair will be 5, 6, 0. So that right there will be the horizontal intercept or the x-intercept as we traditionally call it. Okay, now I'm going to run here to problem number 7. Problem number 7. It says the following table gives a jet's height above the ground in feet as a function of time in seconds as the jet makes its landing approach to the runway. So it says, is this function linear? Explain. All right. Now, what I'm going to do here, if you look here, when you look at the seconds, this is t, which would be our x value actually, is consistently going up by 20. Okay, now we look here at h. If you notice here, it's consistently going down by 500. So based upon what we learned back in problem number 1, this function is linear. So your answer would be yes. Yes, the slope is constant. So you will write for 7A just yes, the slope is constant. Okay, now we move on to 7B. It says calculate the slope using a formula. M is equal to the change in h. So I do 7B. So M is equal to the change in h over the change in t. Now we already figured that out on the previous page. Let me go back. When I said here h was going down by 500, so that means that the change in h is a -500. And then the change in t is going up by 20. So the change in t would be 20. Now they asked us if we took a negative 500 divided by 20, this would give us a negative 25 feet per second. And that is the final answer for that problem, for 7b. Now 7c, what is the significance of the sign of the slope in part B? All right. Since it's negative, that means that the jet is losing speed.
What should I do?
Oh, you're free to go, Alea, at that time.
Okay.
Oh.
Also, I'm hosting a study session tomorrow, just so everyone knows.
Oh, okay, great. Okay, now getting back to D, 7D, it says determine where the graph crosses the vertical axis. Okay, so basically the vertical axis is basically the y-intercept. So basically, that is where x is 0. And if we go back here, let me go back to the chart. So where x or t is 0, this is the y-intercept, which is the vertical intercept. So it'll cross at 0, 3,500. Then now we have E. It says write the equation in slope-intercept form. So now remember, h is our y. So it'll be h is equal to, now we have our slope, which is a negative 25. And then t is our x value, plus the 3,500, which is our y value of our y-intercept. So that is our formula. Now we go here to F. It says determine a horizontal intercept. What is its significance in this situation? The horizontal intercept is basically the x-intercept. So we would take this equation and we'll substitute in 0 for h, because the x-intercept is when y is equal to 0. And since h represents y, h will become 0. Now we will subtract 3,500 on both sides. So we have negative 3,500 is equal to a negative 25t. We divide each side by a negative 25. And then we will have 140 is equal to t. Now that's actually 140 seconds. So basically the significance of this is, first of all, we need to write this as an ordered pair, 140, 0. And the significance is it tells that the jet lands in 140 seconds. That was the significance of this, that the jet lands in 140 seconds. Okay, now number 9. All right, number 9 asks us to use your graphing calculator to graph the linear function defined by the following equations. Y equals 2x minus 3, y equals 2x, y equals 2x plus 2, y equals 2x plus 5. Okay, what I want you all to do is this here. I'm not going to do number 9 because like I told you all before, I'm not going to do every single problem that I assign you. But what I want you to do in the next class period, you know, if you have any questions over 9A, B, or C, then I will go over that with you. So now we're going to go on to 1.8. 1.8. And we're actually going to page 76. All right. Now, we're supposed to do problems 1 through 11, but I think I may just do about 3 of those problems. So I'm just going to do problem number 1 problem number 5, and then problem number 11. Yeah, 1, 5, and 11. And then the rest, if you have any questions on those, you can ask those next class period. Okay, number 1. It says, write an equation of the line to satisfy the given conditions. The final equation should be solved for the output y. It says the slope is 1/2, the vertical intercept is -1. So we know, again, the vertical intercept is the y-intercept. So we're basically using the formula y equals mx plus b, which is slope-intercept form. And they tell us the slope is 1/2, so it'd be y equals 1/2 x. And then our y-intercept, the vertical intercept, is -1. So we'll write -1. So that is our equation. Y equals 1/2 x minus 1. Now we go here to B. It says the line contains the point -3, 5, and 0, 1. All right, so I guess I'm assuming that they want us to write an equation for that as well. So we add -3, 5, and then also 0, 1. Now we have our y-intercept, but we don't have our slope. So we need to solve for the slope. So we have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So 1 minus 5 is -4. 0 minus a -3 would be +3. So we have our slope, which would be a -4/3. And then we have our y-intercept, which is +1. So that would be our equation. Case C, the slope is -3 and the line contains the point -2, 1. Now with C, we have our slope, which is good, but we don't have our y-intercept. So we could put in our slope, which is -3, but we don't know what B is. So we have to go and solve for B. But we're given a point, the point -2, 1. So we would substitute these values in and then solve for B. So y would be 1 and x would be -2. So it'd be 1 is equal to 6 plus b. Subtract 6 on both sides, and -5 is equal to b. So our equation would be y is equal to -3x minus 5. Now we move on to D and E. D, it says the line contains the point -4, -3, and 2, 6. Now in this case, we're not given either one. We don't have the y-intercept and we don't have the slope. So first, let's find the slope. So y sub 2 is 6 minus y sub 1 is -3. X sub 2 is 2 minus x sub 1 is -4. So our slope here would be 9 over 6, which when we simplify would be 3/2. Okay, so that's our slope. Now we would have y is equal to 3/2 x plus b. Now we could take one of these 2 points. It doesn't matter which one. I would take the 2, 6. I'm going to take the point 2, 6 and substitute them in for x and y. So y would be 6 and x would be 2. So this would be 6 is equal to, these 2's will simplify out and leave 3. So we'll subtract 3 on both sides. And we add 3 is equal to b. So our final answer would be y equals 3/2 x plus 3. Okay, now for E, it says the line is parallel to the line y equals 3x minus 7 and passes through the point 2, -5. Recall that parallel lines have the same slope. So they gave us a real big hint there. Since they're parallel, they have the same slope. When we see this equation here, y equals 3x minus 7, we know the slope is 3. So we know with our new equation, we had a slope of 3, but we had a point 2, -5. So we'll go through with our y equals mx plus b. So it'll be y equals 3x plus b. We'll substitute in 2 for x and negative 5 for y. So it'll be negative 5 is equal to 3 times 2 plus b. So negative 5 equals 6 plus b. Subtract 6 on both sides, and negative 11 is equal to b. So now we can write our equation. Y equals 3x minus 11. And that is our final answer for problem number 1. So then I said the next problem would be problem number 5. Okay, problem number 5. It says here, the following graph represents the distance from home of a car as a function of time in hours. Okay, so with 5A, it says, how fast is the car traveling? Okay, so when they're asking how fast, typically if someone asks you how fast you're traveling, you would say some value per hour. So that is your constant rate of change, or your constant rate. So if we do 5A, what we would need to do here is first find 2 exact points. Now here's one exact point here at, let me see. Oh, wait a minute. Let me see, it's 1, 2, 3, 4. Okay, so if we go, this would be 1. Yes, we could do 1 and 2. So this would hit here at 2. So, okay, so at 1, we have 1 comma 75. And then at 2, we will add 2 comma, if you notice here, this is going up by 25. So that'll be 2 comma 125. So those are our 2 points. So we need to find the slope. So we have m is equal to 125 minus 75 over 2 minus 1. So this would be 50 over 1. So the slope would be 50. So our answer to A would be 50 miles per hour. Now we go here to B. It says determine the vertical intercept. Now the vertical intercept is the y-intercept. And you notice here the point that's hitting at the y-intercept would be 0, 25. So it'd be 0, 25. That would be our B. Now we go to C. It says write the equation of the line in slope-intercept form. So we know that slope-intercept form is y equals mx plus b. But if you notice here, since we're actually using time, we could change this to y equals mt plus b. And then now we substitute. The slope here is 50, so it'd be 50t plus, and then we know the y-intercept would be 25. So it'd be y equals 50t plus 25. Okay, now, the last problem would be problem number 11. Okay, number 11 is kind of lengthy, but we're going to get through that. Okay, and again, if you have any questions about any of the previous problems, let me know. The ones that I didn't cover, you can ask them next class period, or you could even email me and I will try and get you an answer ASAP. All right. It says the basal energy requirement is the daily number of calories that a person needs to maintain basic life processes. For a 20-year-old male who weighs 75 kilograms and is 190.5 centimeters tall, the basal energy requirement is 1,952 calories. If his weight increases to 95 kilograms, he will require 2,226 calories. The given information is summarized in the following table. Okay. Assume that the basal energy requirement B is a linear function of weight W for a 20-year-old male who is 190.5 centimeters tall. Determine the slope of the line containing the 2 points indicated in the above table. Okay. So basically, if we write out the ordered pair, we will have 75, 1,952, and then 95, 2,226. Okay, so we would do the slope. So the slope we had 2,226 minus 1952, all over 95 minus 75. Now 95 minus 75 is 20, and 2,226 minus 1,952 is 274. So 274 divided by 20 is actually 13.7. So the slope here is 13.7. Now that's 11A. Now we go here to B. It says, what is the practical meaning of the slope in the context of this situation? Okay, so basically, for each additional 1 kilogram increase in weight will increase the basal energy requirement by 13.7 additional calories. So in a nutshell, for every kilogram you go up in weight, you're going to have to increase your caloric intake by 13.7 to get the basal energy requirement. So basically what it's saying is that in order for you to maintain that weight, you will need to go up to that value. Okay, now C. It says using a point slope form, determine an equation that expresses B in terms of W for a 20-year-old 190.5 centimeter tall male. Okay, so all right. So we'll have B is equal to K plus M times W minus H. Now, if you look back up here at this chart, we see what W and B is, and we also figured out what K was. K was basically your caloric intake, which would be your calories, which would be the B. So we have B is equal to 1952 to be your caloric intake, plus, now we know our slope is 13.7, and then we have W minus 75. Now we have to go through and solve this, where we would end up getting, well, B is already by itself, but we have to combine like terms here. So we had 1952 plus 13.7 times W would be 13.7 W. 13.7 times this negative 75 will give us a negative 1,027.5. So now we combine the like terms. We have 13.7 W plus 924.5. Now, basically, this was another roundabout way when you're using the point slope form. This is another way of finding the slope intercept form. So if you notice here, we end up getting back into slope intercept form. Okay, now we go to D. It says, does the b-intercept have any practical meaning in this situation? Now, what the b-intercept basically would be is when W, or actually W, which is your x value, would be 0. And we know that no one has a weight of 0. So it would have no practical meaning because no one weighs 0, what's that, kilograms. So that would basically be it. So that's basically it for 1.7 and 1.8. Again, for the problems that I did not cover, if you still have questions on those, feel free to contact me. Have a wonderful day.